Hi, welcome back to Unit 9, Limits and Derivatives. For this video number 5, we are going to be looking at the definition of the derivative. This is to be used with an in-class worksheet. The top of your worksheet looks very similar to this. And let me give you an explanation of this picture. So what we have here is we're taking a look at our function. F of x is this kind of teal color graph that I'm putting arrows on. And we're taking a look at evaluating at x. We would get this, the y value f of x. So that would be your ordered pair at that place. And then they've got some, any value, any arbitrary value h that we've added. It's a distance, a certain distance away from x. It doesn't have to be a large distance away. It's just some place away from x. And then we can evaluate up here, and we would have f of x plus h. Well, what if we were to decrease that amount and say, let's say maybe we took it to here, and so we'd have x plus h1, so a different value of h, a different distance away, that this would give us our f of x plus h1, a different y value. And if we continue to decrease that amount that we were looking at, so say we got to here and then we got even closer, that our values would decrease, and these lines that were secant lines connecting these 2 points would eventually become a tangent line, or appear to be a tangent line because we were so close. So we have this rate of change, this line that's occurring, this slope between those two lines, and eventually when we get here, we call that an instantaneous rate of change. So the slope formula that we're using, if we were to apply it to our f of x and f of x plus h, would be this. Here's our y values, and those are our x values. Because we have x plus h minus x in the denominator, looking at our x values, it just simplifies to an h. So the derivative of a function at x is denoted by f prime of x and is defined by f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h, provided the limit exists. Well, what does all that mean? Basically what it says is that we are going to approach a space of nothing. If h is defined as the space that we're moving away from x, we want to move so close to x that there is no space. So this defines the space that we want to eliminate, so 0 space. Now, as I write this, you need to make sure that you are noting everything the same way I do. So I'm going to have f prime of x equals the limit, and I'm going to write this every time. It's the definition. F of x plus h minus f of x all over h. Now I will substitute. I'm going to have the limit as h approaches 0, and I'm going to substitute in x plus h into my x position. So I will have 4 times x plus h plus 2 minus the original function, that's the whole thing, 4x plus 2. I'm going to put that in parentheses because I am subtracting the whole thing, all over h. And I'm going to start to simplify. The limit as h approaches 0 of 4x plus 4h plus 2 minus 4x minus 2 all over h. That was me distributing the 4 and the negative sign. Cleaning it up. The limit as h approaches 0, my 4x's cancel, my 2's cancel, and I'm left with 4h over h. I'm going to reduce. The limit as h approaches 0 of 4. We know that when we take the limit of a constant, the answer is the constant. So I could write my answer as f prime of x equals 4. Let's try the next one. I'm going to start with the definition. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I'm going to substitute. The limit as h approaches 0, and this time I'm going to put it in parentheses, x plus h squared plus 3 times x plus h, and I'm going to subtract the entire original function, x squared plus 3x, all over h. In my next step, I'm going to expand x plus h squared and distribute the negative and the 3 on the next parts. The limit as h approaches 0, I'm going to have x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x all over h. In the next step, you'll see the cancels, x squared cancels, 3x's cancel, and I'm left with the limit as h approaches 0 of 2xh plus h squared plus 3h all over h. I'm able to factor an h out of everything, which will eliminate the h in the denominator. So I'm going to have the limit as h approaches 0 of 2x plus h plus 3. Now I can substitute in my 0. The previous one there was no h to substitute, but this one I've got an h left over. So I substitute in the 0, and I get for the final answer 2x plus 3. So my f prime of x, my derivative, is 2x plus 3. Next problem. All right, got 5x squared. So I'm going to start again with my definition. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting in, I get the limit as h approaches 0 of 5 times x plus h squared minus 5x squared all over h. I'm going to first go ahead and expand the x plus h. So I'm going to have 5 times x squared plus 2xh plus h squared minus 5x squared all over h. Next, I will distribute the 5, and I will have 5x squared plus 10xh plus 5h squared minus 5x squared all over h. Next, we will cancel, and we will see that my 5x squareds cancel, and I have 10x squared plus 5h squared over h. Oops, h, that should be an h. Okay, and I can take an h out of everything, and I'm left with the limit as h approaches 0 of 10x plus 5h. Now I can substitute in a 0 for h, and I will end up with f prime of x equals 10x. All right, we've got one more, and I might end up going on to the next slide depending on how large I write here, but we'll do our best to get it on here. So I'm going to start with my definition. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h equals the limit as h approaches 0 of 2 times x plus h squared minus, in parentheses, x plus h minus 3 minus big parentheses 2x squared minus x minus 3 all over h. Next line, the limit as h approaches 0. And I'm going to expand this x plus h, distribute the negative, and distribute this negative over here. I'm actually also going to distribute this 2 as I expand it. So I'm going to have 2x squared plus 4xh plus 2h squared minus x minus h minus 3 minus 2x squared plus x plus 3 all over h. So I am going to go on to the next slide, and in the next slide you're going to see that I've canceled my 2x squareds, that I've canceled my x, that I've canceled my 3's. And what I'm left with is 4xh plus 2h squared minus h over h. On to the next slide. So I've got the limit as h approaches 0 of 4xh plus 2h squared minus h all over h. Here I'm actually going to show you me factoring out that h. So I'm going to have h times 4x plus 2h minus 1 all over h. And the reason I'm showing you is because that minus 1 is extremely important. Now I can cancel my h's, and I have the limit as h approaches 0 of 4x plus 2h minus 1. I can substitute in the 0 for the h, and I get f prime of x equals 4x minus 1. And that is my derivative. So a couple key important things is that you must write the limit as h approaches 0 on every step. The only time it's done is when you go ahead and you substitute in your h equals 0. Then it's written f prime of x equals, and of course your answer. But this step is extremely important because you haven't taken the limit until you've substituted in 0. So you can't just ignore that part of it. All right, we're going to practice these tomorrow in class. We'll get some more practice of writing them out completely, and they do take a number of steps, but this is probably the longest process that we've got, and you're going to be very good at it by the time we finish.